Alright, hello. We're doing vocab and sampling methods. There's a lot of vocab when it comes to stats, so get ready to know a lot of words. Alright, so population. With population, this is the entire group of individuals, and I'll just read it out, individuals that we want info about. So it's an entire group of individuals that we want info about. Now, that's something that we're going to be using a lot with population. Same with sample. This is another important term. So sample is the part of the population that we actually examine in order to gather information about. So this is a part of the group that we will take information from. And then another important term, parameter, is the value that represents a population. And it's just typically represented by Greek letters, and again, we'll get into more of this as we go on, but filling out these vocabs. Statistic is a value that represents a sample. So this is not represented by Greek letters. Okay, so statistics are usually a little bit smaller or not as good as parameters. A census is a study that includes everyone in the population. So you know, with the United States, we have a census every 10 years, and they must get every single one so that they can count the population of the United States. Alright, and we will not be doing these, so we don't have to worry about them. Alright, and then comparison, control, randomization, and replication are main components of an experimental design. And Ms. Ganlon will get more into that. Survey is a study that is obtained from a subset of a population, okay, in order to estimate population attributes. So one thing that they do for the census is send out a survey. Or, you can get surveys from restaurants, like asking how your meal was or whatever, something like that. Alright, and then we have sampling design is a method to choose a sample from the population. So in order to be in the sample, sometimes they send a method, so like a survey to get into the sample. Alright, probabilistic sampling design involves a random selection which guarantees that everyone in the population has an equal chance of being chosen. So it's always good to do random samples that have no bias, and we'll get more into that word later, but there can be no favoritism on my part or your part, anybody's part, so that randomization is what we need. Alright, and we have parts of this probabilistic sampling design. So we have simple random sample. So all the groups of the sample size have the same chance of being selected. So when you get your student ID here at AFHS, it's randomly selected numbers, and that way it has an equal chance of each number being used. Alright, and then we have systematic random sample. The researcher selects a number from 1 to k at random, keyword random, call it k, then selects every k plus an to the nth individual for the study, so where a is at 1, 2, or 3. So this is an example would be at the airport when they select you for random sample. They just kind of take one number at random. Doesn't know who it is, but it'll always be random. Alright, stratified random sample. So the researcher divides the entire target population into homogeneous subgroups, or strata is another word for it, and randomly selects the subjects proportionally from the different strata. So we're going to divide all the students at AFHS into 4 homogeneous groups. We have freshmen, sophomores, juniors, and seniors, and we're going to choose an SRS from each grade level. So that's how I could find them. And we could even do even more homogeneous groups with male and female within the grade levels. Alright, cluster sample. The entire population is divided into heterogeneous groups or clusters. And a random sample of one or more of these clusters are selected. All individuals in the selected clusters are included in the sample. So example, I could randomly choose one of the floors of the building during first period and survey all the students on that floor. All grades would be represented because it doesn't matter. We don't have grade levels selected for floors. We have classrooms. So that would be a cluster sample. So we have non-probabilistic sampling design. So we have voluntary response samples. So subjects that select themselves in an online survey. So an example would be like asking for volunteers to stop by my classroom and pick up a survey, or asking for a survey from a restaurant saying like, how did you like my restaurant? Well, you select yourself to give a survey for a restaurant, but it's not always, all that. So there are problems with this. We have strong negative opinions, tend to volunteer, or they have something in common that sets them apart from who do not volunteer. That's why this sample is not representative of the population always. And then a convenience sample. So subjects are taken from a group that is conveniently accessible to the researchers. So distributing a survey to students in my class, but that's not representative of the whole entire AFHS population. Alright, bias. I said I was going to get into this. So bias occurs when sampling method systematically favors one outcome. So I don't like fish, so I would be like, oh, let's give a survey on fish, and I know I would word those questions in a way that favors that people don't like fish. Okay, so under coverage, when some groups of the population are left out. So if I knew some people that liked fish, I would purposely leave them out because I didn't want them to like it. Non-response bias is when a sample member can't be contacted or refuses to respond. That would be on their part. Response bias, when individuals are dishonest or may answer the question untruthfully. So lying on a survey, that's why you have to swear under oath whenever you go to court so that you don't lie. And it's also against the law. Perjury. Wording of the question. So poorly worded questions can result in response bias. So if I worded the question, fish has a bad smell, do you agree with me? Yes, fish has a terrible smell. So, that would get them to not like fish. Alright, so voluntary response bias, when the sample members are self-selected, just like before, these are usually people with very strong opinions, usually negative. So if I saw a survey on how people don't like fish, I would strongly go into it because I hate fish. Alright, convenient sampling. So sampling people who are easy to ask. So again, asking my students in my class about a survey, it's just easier that way. And then lastly, we have lurking variables. Are variables that affect results in a study but may not have been taken into consideration by experimenters. So someone who is allergic to fish may not be taken into account when we give out surveys. Some things like that, alright? So please make sure you do understand these vocab words. They will come back to haunt you for this, and in Math 4 or Pre-Calc, they will come back to haunt you, so you must know these words. So let's move on. So if you use the guided notes, you might notice that there is a lot. I'm not going to do every single one of these, but I will post a key to every single one of them if you want to practice on your own with the notes, and then also that independent practice. So again, we're not going to go over every single one of these, but I digress. Alright, so talking about parameters. So if you remember, parameters are the value that represents a population, and we also have to tell the difference between parameters and statistic. So a parameter is the value that represents a population. This is a lot better in terms of non-bias. But we also have statistics as a value that represents a sample. So we're taking a group from the population and we're taking that statistic. So let's talk about these problems and see what's going on. So the National Endowment of the Arts conducted a survey titled Reading at Risk on the reading habits of approximately 17,000 adults. Of those surveys, surveyed, only 57% read a book in 2002. So what is the population under investigation? So that would be the adults in the U.S. Okay, so we have adults in U.S. What is the parameter at interest? So it is the reading habits of the adults. So percent of adults who read books. Okay, and then what is our sample? Well, our sample is the 17,000 adults. And then what is the sample statistic? Meaning what is the information that they gathered? And that is that only 57% read a book. Okay? So that is why this is a statistic, because we can't get every single adult to answer this question, so this is why it's a statistic and not a parameter. Okay? A recent survey by the alumni of a major university conducted the average salary of 10,000 of its 300,000 graduates was $125,000. So what is the population under investigation? It is the alumni of that university, so the alumni. Okay, and then what is the parameter of interest? And that's going to be our average salary. So average salary. And then what is the sample? Well, the sample was the 10,000 students of the 300,000. So the 10,000 alumni. And then what is the sample statistic? And then that is what they found, and it was 125,000. Was the average salary. Okay? Alright, so I'm not going to do number 3, but you kind of get the gist. So now we're going to use this information to determine whether a value is a parameter or it is a statistic. So, the average salary of all assembly line employees at a certain car manufacturer is $33,000. This is a parameter because the population is the car manufacturer, and they can easily get that information about their employees because they have it on hand. Okay, the average late fee for 100 credit card holders was found to be $56.75. That is going to be a statistic because there is way more than 100 credit card holders. There is thousands upon millions of people who have a credit card. 10% of physics majors at NC State University were double majoring in math. This is going to be a population. This is something that they can gather from their records. They can see 10% of their physics majors are double majoring. It is something that's on record. The average IQ score of a college student in math class is 115 with a standard deviation of 10. This is a statistic. So it's asking for the IQ score of college students, but it's in a math class, and this is not representative of the whole population of college students because it's only that math class. Acme Corporation manufactures light bulbs. The CEO claims an Acme light bulb lasts 300 days. This is a statistic. Reason being, we can't test the entire population of light bulbs because then we wouldn't have any more light bulbs to test. Alright? So number 9, the owner of a fish market determined the average weight of a catfish is 3.2 pounds. This is a statistic, again, because catfish weight varies over time, even from month to month, depending upon the seasons. Catfish weight is, not always the same. And the Pew Research Center reported that 24% of adults did not read a single book last year. Well, this is a statistic because you cannot ask every single adult in the world what their opinion is. It is just not feasible. Alright, and then lastly, incoming freshmen at 2013 in NC State University average SAT score is 625. This is a parameter. They have that information on file, so yes, they can do this. Alright, part 1 is done. Now, go to part 2.